Hello class, and welcome to another class with Professor Choi. Today we are continuing our conversation about how to minimize the error when you have a sample versus a population, and basically how to figure out how to make your sample better and more accurate, to try to represent population. Now, one of the conversations that we've been having is the fact that in statistics, a lot of the times we don't really collect population. As a matter of fact, most of the time we don't collect population. Instead, what we do is we collect sample, and then we make assumptions of sample into population. Because we do that, then we need to know that there's going to be an error, and the error could be quite significant. Therefore, we need to try to figure out ways to minimize that error so that when we use a sample and then try to put it into population, we're doing our best job possible, and therefore we're not misinterpreting what the sample is telling us about population. Alright? So today we're going to talk a little bit about something we call the central limit theorem, and I always like to start that one by explaining what a sample distribution of a sample mean is, so you understand the best type of way of conducting these samples to try to figure out how to maximize our correct answer. Okay? So a sample distribution of a sample mean is basically the distribution of all different sample means of a particular population. Now imagine that we have, say, 10 people in your population, and you're trying to figure out, and you're trying to collect samples of 5. Okay? So we have 10 people in our population, and we're trying to collect different samples of 5. Now remember, there are multiple ways of doing this, because when we have 10 people, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I could collect these 5, but I could also collect these 5, but I could also collect these 5 without including the first one, or I could collect these 5, or I could collect these 5, or I could collect this guy, this guy, this guy, this guy, and this guy, and that would be 5. So there are a bunch of multiple ways to collect 5 people from a sample of 10 people. Alright? As a matter of fact, the answer to that I explained in another chapter, in another video, and the answer to that is 10 combination 5. Okay? So if you're going to do that, remember on your calculator, you got to watch that other video where I talk about combination and permutation. So look for it. It's the one where we talk about calculating probabilities, and the one about the lotto, if you're looking for it. Alright, in any case, there are 252 different ways to do this particular one. So in other words, collecting samples of 5 out of a total amount of 10 people. Alright? Now, a sampling distribution of the sample mean is when, imagine that you collect all possible samples of 5. All of them. So you take all the different samples of 5 that you can collect from these different 10 people, and you collect every single one of them. Okay, if you were to take the mean of those 10 people, the mean will give you population. But when you're collecting only samples of 5, remember, the sample will never represent population exactly. So the sample might be a little bit to the right of population, or the sample might be a little bit to the left of population. In other words, when you take the mean of your sample, x bar 1, it's never going to be equal to mu. And welcome to having an error. So there's always an error when you are comparing sample to population. And the error is the difference between that population number and the sample that you collected. Now, one of the biggest problems that we normally have is because we don't have population, because we've never collected it, we don't really know a lot of the times what the error is. In other words, we need to estimate the error as well. So one of the problems that we normally have is that we don't know whether we're collecting this sample here, or this sample here, this sample here, this sample here, or that sample there. We just don't know. So every sample you collect, if you do the mean, it's not going to give you the same as a mu. But imagine that you were able to collect all the sample means for a particular population. So you were able to collect all 252 sample means for this population of 10 people. So all samples of 5 for this population of 10 people, which is 252 different combinations. If you were to do that, and you take what we call the mean of means, in other words, you take all of those means and you calculate the mean of all of those means, then the mean of means will give you exactly mu. So the mean of all the means of samples of 5 from a population of 10 will give you exactly the mean for the population. So the mean of means of all the samples of 10 or of 20 will give you exactly population. So the mean of means of all of them will give you population. So if you take all samples of whatever from a given population, or all samples of whatever from a given population, and then you collect the mean of all of those samples and you calculate the mean of all of them, then you're going to get exactly population. As a consequence of what I just explained right here, you need to understand that the best way to minimize an error is to collect lots of samples and calculate then the average of all of those samples. And that will give you the best estimate of population. So let me repeat that. The best way to estimate population is to collect all the samples that you can and then take the mean of all of those samples. And when you calculate the mean of means, you get the best estimate for that population. Alright, now the next thing that we need to talk about is something called the central limit theorem. Now the central limit theorem basically says if all the samples of a particular size are selected from any population, the distribution of the sample mean is approximately a normal distribution. The larger the sample, the better. So if we were to select all the samples of a particular size from any population, the distribution of the sample mean is approximately a normal distribution along the center, and the larger the sample, the better. So what the central limit theorem is basically saying is that the larger the sample that we collect, when we do all of those, a lot of those samples, then we approximate a normal distribution along the center of that population, even if the population distribution is not normal. This is a really good example of what I'm trying to explain here. Imagine that we take the income of everybody in the population. We know that income is unequally distributed. So therefore, we're not going to get a normal distribution. You're going to get a skewed distribution with different incomes. So the average is not going to be in the center with the mean, the median, and the mode. The average is going to be skewed. Alright? And I explained, by the way, this in a different video as well, how income distribution changes the center. Alright? Now in any case, if we were to collect all the samples of a particular size from any population, in this case, imagine that we took samples of 100 people and we were to collect all the samples of 100 people possible. And then we take the mean of those, all of those samples. What we're going to get is the center of the distribution, and it's going to be normal. So the mean of means is going to be the distribution of the mean of means is going to be normal, and it's going to be around the center of our distribution for income. Therefore, again, the best way to minimize an error by collecting a sample from your population, and I may have mentioned this on the previous one as well, is 1, randomize your sample correctly, and 2, collect large samples. Now, according to this, there's a third thing that you could do. Collect lots of samples. And the more the better. So, the best way to minimize the error of a sample compared to a population is 1. Random sampling. 2. Collect large samples. The larger the better. And 3. Calculate the mean of means. In other words, the mean of all your different samples is your best estimate of your population as long as you did randomized samples and collected very large samples. Not only that, if you collect all of them, you start getting normality, which is very useful because then you can talk about, as I mentioned on a previous one, the empirical rule and things like that, so you can do probabilities. Okay? So, this is the best way to minimize an error of a sample compared to population. Therefore, the best way to have a sample estimate a population correctly. Alright, well, I hope you liked my video today. Thank you for sticking with Professor Choi. Have a good one.